Hello guys and welcome back to COVID-Q YouTube channel. So today we will explain about the vaccination of COVID-19. Vaccination is a simple, safe, and effective way of protecting people against harmful diseases before they come into contact with them. It uses your body's natural defenses to build resistance to specific infections and makes your immune system stronger. Vaccines train your immune system to create antibodies, just as it does when it's exposed to a disease. However, because vaccines contain only killed or weakened forms of germs like viruses or bacteria, they do not cause the disease or put you at risk of its complications. Most vaccines are given by an injection, but some are given orally, by mouth, or sprayed into the nose. To understand how COVID-19 vaccines work, it helps to first look at how our bodies fight illness. When germs, such as the virus that causes COVID-19, invade our bodies, they attack and multiply. This invasion, called an infection, is what causes illness. Our immune system uses several tools to fight infection. Blood contains red cells, which carry oxygen to tissues and organs, and white or immune cells, which fight infection. Different types of white blood cells fight infection in different ways. Macrophages are white blood cells that swallow up and digest germs and dead or dying cells. The macrophages leave behind parts of the invading germs, called antigens. The body identifies antigens as dangerous and stimulates antibodies to attack them. B lymphocytes are defensive white blood cells. They produce antibodies that attack the pieces of the virus left behind by the macrophages. T lymphocytes are another type of defensive white blood cell. They attack cells in the body that have already been infected. The first time a person is infected with the virus that causes COVID-19, it can take several days or weeks for their body to make and use all the germ-fighting tools needed to get over the infection. After the infection, the person's immune system remembers what it learned about how to protect the body against that disease. The body keeps a few T lymphocytes, called memory cells, that go into action quickly if the body encounters the same virus again. When the familiar antigens are detected, B lymphocytes produce antibodies to attack them. Experts are still learning how long these memory cells protect a person against the virus that causes COVID-19. After we have been exposed to an infection, our immune system remembers the threat in particular by producing antibodies. These are proteins that circulate in the blood and throughout the blood. They quickly recognize and disable the invader, thereby preventing or minimizing illness. This is why we usually do not get sick. With the same bug twice we are immune. Vaccines mimic this process, encouraging the immune system to make antibodies, without us having to go through the illness. Some of the leading SARS-CoV-2 vaccine candidates are mRNA vaccines, based on incorporating the genetic the virus surface into a formula that when injected into humans, it instructs our own cells to make the in turn. The body then makes antibodies against the spike protein, and they protect us against viral infection. This strategy is faster than more traditional approaches, which often involve generating weakened or inactivated forms of a live virus, or making large amounts of the spike protein to determine whether they can prompt an antibody response. Once a potential vaccine is discovered, a number of checkpoints exist before it can be administered to people. First are preclinical tests, which involve experiments in a laboratory and with animals. Candidate is not only effective, but also safe. For example, an antibody response to an imperfect vaccine could, under extremely rare circumstances, end up increasing the danger of becoming infected. When the potential vaccine achieves the necessary preclinical results, clinical trials can begin in a small group of people. As the vaccine candidate advances, it is tested on increasing numbers of people, with scientists and doctors closely monitoring safety, efficacy, and dosing. Upon successful completion of clinical trials, the vaccine candidate must be reviewed and approved by regulatory agencies such as the FDA, before large-scale manufacturing and distribution gets underway.